So I've posted several videos discussing and demonstrating the potential of sound vibrations to ease the movement and manipulation of large masses in both the horizontal and angled dimensions, even suggesting that the ancient builders may have employed similar techniques to assist them in moving around huge blocks of building stone. But what about vertical movement? It has been suggested that sound vibrations could also help with moving of heavy weights in the vertical direction against gravity. But how? Stay tuned as I attempt to answer this very question, as well as how it may relate to John Keely's concept of vibratory lift. In a previous video, I talked about John Keely's vibratory push process as part of his aerial suspension and navigation system. Though vibratory push was somewhat difficult to define, it seemed to be envisioned as a type of pressure force arising from increased molecular oscillation related to centrifugal force and perhaps even a mechanism of horizontal propulsion. It is also related to what Keely called vibratory lift, the other aspect of his propulsion system. Vibratory lift is simply defined as levitation caused by vibration, and hence could be used to describe different types of acoustic lubrication, such as modern containerless processing, as well as John Keely's weights and jars experiments. Keely's description of his fully developed concept of aerial navigation expounds on the description of vibratory lift as employing vibrations that would enable a craft or object to come under the influence of the terrestrial and celestial streams of energy, accessing and riding those energetic streams as a boat floats on currents of water. According to Keely, certain orders of vibration would tend to cause levity, while others would tend to cause increased gravitation. Levity is said to be governed by terrestrial propulsive and celestial attractive, which would cause an object to rise, while gravitation is said to be governed by the terrestrial attractive and the celestial propulsive, which would either cause a levitated object to descend from its lifted height or a grounded object to become heavier, even to the point of being buried into the ground. But this concept sounds quite complex and well developed. Writings on Keely suggest a somewhat steady progression in the complexity of his ideas and concepts, with him discovering many of his basic principles of vibration, such as water cavitation and matter disintegration, purely by accident. For instance, in his early experiments with water, Keely noticed that at a certain order of vibration, the water would turn into a vapor, which he called ether. According to the document here, he had not taken notice of that particular frequency at which this event happened. It was only able to reproduce the effect after a systematic approach, starting with a frequency of 100 until he again reached that vaporization or etherization frequency. In this, Keely was very similar to Thomas Edison in his approach to invention, and like Edison, he didn't always work singularly from mathematical calculation or rigid scientific process, but also largely through trial and error. And so, it is highly likely that Keely's early experiments with vibratory lift also followed a similar pattern. And if so, then it is possible that Keely began his vibratory lift experiments by subjecting various masses to strong acoustic vibrations of varying frequencies and combinations of frequencies. Apparently, it was during one of such vibratory lift experiments that Keely discovered a method of disintegration by accident. During these early vibratory experiments, he probably would have observed that the vibrations reduced the friction between the masses and the surface upon which they were resting, making them much easier to move around. We understand this principle today as acoustic lubrication, a process by which acoustic vibrations introduce cyclical separations between the contact surfaces thus reducing the friction coefficient. Though it is not levitation, acoustic lubrication, by this definition, could indeed be described as a rudimentary type of vibratory lift. It wouldn't be too difficult to envision how Keely's work with vibrations could eventually progress from acoustic lubrication to full-out acoustic levitation. We can see some progression in acoustics even today, starting with containerless processing and contactless positioning, to the more recent acoustic tractor beam. Though even this impressive technology is still very basic when compared with descriptions of Keely's fully fleshed out concept, which aim not to merely lift and hold lightweight objects, but to actually alter the apparent weight of very large and heavy objects. And how might this fit in with descriptions of acoustic technology in the ancient world, as implied in the stories and legends from antiquity? Stories of archaeoacoustics in relation to moving large objects seem to fit into one of three categories. One category is propulsion, perhaps via surface acoustic waves or a vibratory push, seemingly referred to and referenced in ancient stories as heavy stones moving as though having a life of their own. Another category is partial weight negation, which temporarily makes the mass much easier to lift. And still another category is full levitation, in which the heavy object actually rises into the air from just above the Earth's surface to any desired height in the atmosphere. Such a stratified technology might also make us curious as to the beginnings of this ancient sonic technology and how its less developed iterations might have also been used in early megalithic construction. In my video, The Sonic Ramp, we've seen models showing that it is indeed feasible that acoustic lubrication could have been used to reduce friction, rendering an object easier to push or pull up ramps or over flat surfaces, and that perhaps the ancients could have used the techniques in their earliest attempts to harness sound for construction purposes. If acoustic lubrication was the earliest stage, then perhaps weight negation and levitation was achieved in the later stages of the sonic technology. But perhaps there is another intermediate form of sonic technology, which, while less advanced than weight reduction and levitation, would still be very useful in easing the burdens of the builders. In the video Vibratory Push Process, I demonstrated how a resonating object moving horizontally in a given direction due to surface acoustic waves could be propelled in the opposite direction when running into a stationary object due to sonic reflection. The question is, could this same principle also work in the vertical direction? The following demonstrations hint at the possibility. It is certainly reasonable to assume that the ancients made ample use of levers, wedges, and perhaps even proto-cranes such as the shadoof in order to better manipulate heavy masses of building materials weighing up to 2.5 to 3 tons or so. But for the much heavier blocks, these tools likely would have been inadequate in and of themselves unless used in conjunction with supplementary techniques. Could vibratory lift have been one of those techniques? Could a stone being made to resonate at sufficient energy be rendered easier to manipulate with a lever or crane by temporarily countering some of the stone's weight? This may indeed be possible. Of course, many would scoff at this idea and suggest that the technique is simply too complex and too involved for the people and technology of the time, and that leverage and the brute force of numerous people is much more likely. However, the ancients understood much about the vibratory nature of the universe and would likely have realized the advantages of vibratory and oscillatory energy, as these principles allow one to continuously add energy into a system at resonance and be able to achieve a very large output with relatively small amounts of repetitive input energy. Hence, a technique like vibratory lift or vibratory push could potentially generate energy sufficient of exerting tremendous forces far beyond that which is possible by brute force alone. We can understand this concept further by revisiting the article entitled "The Real-Life Experiments That Reveal the Ancient Art and Techniques of Building Egyptian Pyramids," written by Mike Molyneux, mentioned in the video The Sonic Ramp. The subsection entitled "Acoustic Energy for Shifting Large Stones" explains the results of model experiments with pendulum rams. The scaled-up technique would involve several people holding heavy wooden rams by straps over their shoulders and torsos. By swinging the ram back and forth, enough rhythmic energy is developed to propel a large block forward as the ram comes in contact with it. Some of the energy would be reflected back into the ram, which would then swing in the opposite direction. As the ram moved forward again, it would contact the block again and inch it slightly forward. Once the energy begins to diminish, the operators could simply step a short distance back and start the pendulum into full swing again to redevelop the energy, and then repeat the technique until the block is finally at its destination. Perhaps this reflects the idea of some observers who've mentioned that the large blocks were placed so precisely and closely that they seem to have been tapped into place. This principle shows how a powerful force can be developed over time with relatively small but continuous efforts. The force developed by the oscillating pendulum at resonance could be much greater than singular maximal efforts. The same principle would work with vibrations, and hence could potentially be applied to the concept of vibratory lift. We can also see this concept at work in the more familiar tuning fork ping pong ball experiment, in which a tuning fork vibrating at its natural frequency propels the ping pong ball upon contact. It is essentially the same principle as the pendulum ram, but just with a much higher frequency. This could be called horizontal vibratory push, but if we take the system and then rotate it 90 degrees, we could get vertical vibratory push or vibratory lift. In the next experiment shown here, we can see a more powerful version of this principle using the internal vibrations of an electromechanical vibrator. The small vibration displacements within the vibrator trigger exaggerated oscillations at the other end of the lever, which, if coincided properly with rhythmic physical effort, could ease the lifting and moving of a mass using levers, cranes, wedges, and perhaps even supplement moving techniques such as those demonstrated by Wally T. Wallington in his Forgotten Technology video. Here, the diagram shows the concept of using vibratory lift being used to supplement a proto-crane like the shadoof that was used in ancient Nubia, Egypt, and India, and is still used today. Such a device would enable the movement of heavy masses horizontally across the workspace as well as vertically. It is even theoretically possible to propel the mass quite high if sufficient vibratory energy were to be developed. We would also want to take the natural period of the lever or crane into consideration. By choosing dimensions that are not only long enough to yield physical leverage advantages, but which also would produce a machine with a natural swinging period, which is a subharmonic of the frequency of the vibrating mass, it might be possible to maximize the energy of the entire system. It would then be significantly easier to move the large weights across the workspace as long as it is within the lifting machine's reach. Though a vibrating device could be attached to the mass as shown, it would probably be more practical to resonate the mass itself, just as the tuning fork in the aforeshown clips. The resonant frequencies of granite is 6900 Hz, and that of sandstone is 8700 Hz, and likely a number of resonant harmonics in the ultrasonic range. But according to the article here, the resonance frequencies of the rocks are different under different ranges of excitation frequencies. As the excitation frequency increases, the resonant frequency of the rocks also increase. Thus, the operating resonant frequencies may not always be a matter of simple whole number ratios or harmonics of the base resonant frequencies. And so novel ways of finding the frequencies of the stones will be vital. But even still, ultrasonic resonant frequencies might be desirable, as there would be less translatory tapping. If we were to scale this technique up, then this tapping as demonstrated here would likely be undesirable, as the rapidly repeating high impact contact with the ground would likely result in damage to the stone. Instead, we would want the vibratory energy itself, rather than the oscillatory tapping, to be the propulsive force. Keely described vibrations as the rhythmic movement of a body within itself, slightly different than oscillation, which he defined as the rhythmic translational movement of a body. So they are not exactly the same, but both can give rise to the other, as they both are manifestations of rhythmic mechanical energy. Like with the vibratory push principle demonstrated in the video Vibratory Push Process, in which a push is generated by a simple touch, vibratory lift is also possible by simple contact between the resonating mass and the ground, allowing for internal reflection of the energy without the need for the translatory tapping. This internal vibratory energy would be sent into the ground upon contact with it, the result being the reflection of this energy by the ground and back into the stone in the mechanical system, ending in a temporary vertical push or impulse against gravity. The vibrational pushes would coincide with the manual physical forces from a lever, a crane, or a hoist. Another way to understand this is with a Newton's cradle, in which an impact from one end ball can travel through the middle balls, which remain physically stationary, to the opposite outer ball, which translates. In effect, we have an initial translatory impulse or oscillation being converted into a vibratory impulse and then back into a translation. We can equate the pulled starter ball, which is the source of the original impulse of rhythmic energy, to the vibrational energy within the resonating stone. The energy then travels through the ground, but of course the ground does not move, just as the middle balls of the Newton's cradle do not move. Instead, the impulse is reflected back into the mass, acting on the mass and pushing it upwards, just as the impulse traveling through the middle balls causes the outer ball to be temporarily repelled. The cycle then repeats. In effect, it would function similarly to the acoustic shifting technique with the pendulum, but of course operating in the vertical direction. And so, the main takeaway with this basic form of vibratory lift is the ability to build up maximum rhythmic mechanical energy via resonance, and then to release and utilize that energy cyclically by reflecting it back into the system for temporary levity impulses. This reflection can result in significant momentary push forces and is demonstrable on a small scale. But could it be achieved on a megalithic scale? And if so, was it a technique that was used by the ancient builders? Well, If weight negation and full levitation were the end result of this type of sonic technology, then it is certainly possible that vibratory lift, as described here, could have been utilized as a precursor technique before it developed into the ultimate gravity control technique. It has been said that Edward Lee Scoulin, builder of the modern megalith Coral Castle, once floated coral stones in the air like hydrogen balloons. But there are other claims that he didn't levitate the stones, but rather devised methods to mitigate their apparent weight, as he did utilize conventional tools such as the chain hoist as shown here in the photo. However, his chain hoist was said to have been rated at only 10 tons, whereas his largest wall had a weight well beyond that capacity at a mass of 30 tons. Hence the idea that Lee Scoulin employed some type of levity technique in conjunction with his more basic tools, perhaps using electromagnetism, geomagnetism, or perhaps acoustic vibrations in the ultrasonic or radio frequency range, as no loud sounds were ever reported during his construction of the compound. The pan resonator here is another demonstration of this idea. It might help us to further envision a long lever or crane which is stationary but which can swivel, showing how sound vibrations could be used to supplement more conventional lifting techniques. Now, the system as demonstrated here is very far from efficient. There's obviously a lot of wasted energy, but it does show the basic idea of how vibrations can result in significant periodic lifting forces. The main challenge with this vibratory lift concept, of course, will be in generating acoustic vibrations of sufficient energy to affect and move multi-ton stones. In an upcoming video, I will demonstrate a practical method to convert flowing water into powerful sonic vibrations. This is only part 1 of the exploration of the vibratory lift concept. In part 2, we will look more closely at John Keely's concept of gravitation and levitation, and how it may relate to Russian astrophysicist Nikolai A. Kozyrev's more recent work on torsion fields and latent force. Thanks for watching, and as always, stay tuned.